Okay, good morning, children. This we are going to start with the new chapter now, physical quantities and measurement. I'm sure Pranita ma'am has given you the notes for the previous chapter. There are certain things that needs to be done. I'll be doing that in class since school is on from today. So I'll be doing that in class. They stick the appropriate answer and all those things on page number 13. Next class, I promised them. Today we at introductory class. So I'll be doing those things. Please update yourself with the notes that has been given to you by Pranita ma'am. Okay, now we are going to go to chapter number 2. It's called physical quantities and measurement. Okay. So let's go to the introductory lines of the chapter. It says the lightness or heaviness of an object is directly related to its density. Okay, children, see, whenever I talk, this is my thing, whenever I talk about density, the word density, I've always said this to my previous batches of physics students that I taught physics in the earlier years. The moment the word density comes, please the next word that should come to your mind is molecules. Why do I say that? Density, molecules. Why? Because density is all about molecules. Understood? It's all about molecules. Like in matter, we talked about intermolecular space, intermolecular force of attraction, two basic things which would define whether a substance would be in a state of would be in a solid state, liquid state, or a gaseous state, or interchangeable state, or how you can change one substance in any of the states. Okay, this is a very big thing in today's world. We people are trying to, even for that matter, like so many new technologies, so many new discoveries, so many new innovations that are going to come about because of physics. This thing also is a very important thing. Okay, there are so many things like maybe beam traveling and all those things where molecules can be interarranged, it can be dismantled, taken from one place to another in a unit record time and rearranged the way it was. All those things are there. High-end physics, high-end science. So density is out there also when we're talking about intermolecular force of attraction, intermolecular space. We were talking about molecules and how they were arranged, the way they were behaving with each other. Okay. So density is all about molecules. If the molecules are in a unit area, the number of molecules defines the density of that particular substance. Okay. Let's say if the molecules are very tightly packed, density will be high. If the molecules are sparsely packed or loosely packed, density will be low. The density is all about molecules. Okay, that's why whenever the word population is there, we call population density. Okay, the density of the population. What are we trying to say? Population means what? If in terms of humans, we say the number of humans in a particular area, right? It's always according to an area. Like in a village, how many people are there? So the population density of the village. If more people are there in a village, the population density is high. If less people are there, population density is low. Okay. So the lightness or heaviness of an object is directly related to its density. Now, how does lightness or heaviness, the moment we talk about it, we are talking about weight. Okay. Now, how is weight related to density? So what is weight? Weight is again directly related to molecules. More the molecules, more the weight. Lesser the molecules, lesser the weight. Like in a bus, if there are more people in the bus will be heavier. If there are less people in the bus will be lighter. Understood? So density is directly related to, the lightness or heaviness of an object is directly related to its density. That's true. Density means molecules. Okay. So when we say that iron is heavier than wood for a given volume, same volume of iron, same volume. Let's say this is, take these two chalks. They look the same almost. So wood, same volume. Iron, same volume. iron will be heavier, or density of iron will be more. Why? Because the number of molecules being packed in iron in the same area, same volume, will be more than that of wood. So when we say that iron is heavier than wood for a given volume, then it simply means that the density of iron is greater than that of wood. Now, are you getting a density and weight, how they are related? The density of a substance is defined as its mass per unit volume. Mass, again, if you go by the definition of mass, amount of matter contained in a body. Okay, so density is defined as mass per unit volume. That means in a particular volume, what is the amount of mass? Higher the mass, higher the weight, higher the density. Okay, so from this only, density equals to mass per unit volume. Mass per unit volume. That means in a particular volume, how much of mass is there? So this formula will directly D equals to M upon V. Okay. So mass upon volume. Right. So this is the formula of density. Definition is given there in the book. We'll be giving it to you in notes also. Now, measurement of density of irregular solids. What is an irregular solid? Okay, if a solid has all the dimensions in place, like the length, the breadth, which is measurable by tape or by certain methods, by certain instruments, then those are called regular solids. But if you take a piece of wood or rock, whether it's ragged edged, sharp edged or smooth edged, it doesn't have particular dimensions that you can measure. It doesn't have well-defined length, it doesn't have well-defined breadth, height, all those things. Okay, so how do you go about measuring the density of an irregular solid? Okay, so how do we do that? What we need is two measuring cylinders. In fact, a measuring cylinder with the help of which you can measure. Okay, so first and foremost, what you need to do is you need to, let's say there's a measuring cylinder. Okay. So let's say we put water as the initial level in the markings. Okay, so you take an irregular solid, let's say a piece of stone. Okay, we need to find the density of the stone. And what is the formula for density? Mass upon volume. So we need to know the mass of the stone and we need to know the volume of the stone. We'll see how we do that. To find the weight of the stone, you just simply take the stone, weight, physical balance, or whatever modes of weighing are there, all the instruments that can be used. Just weight and mark the mass. So mass, let's say X grams. Okay, taken. Now you tie this stone with a string, thin rope. Okay, and then you, in the measuring cylinder, you take the volume. So let's call this volume 1, reading 1 or volume 1, and you note volume 1 Y milliliter. Okay. Now you take the stone and you put the stone, immerse the stone in the measuring cylinder which contains the water. Now what will happen? A new reading will come up, because when you put the stone inside the measuring cylinder, water gets displaced, so the water rises up. This becomes volume 2. Okay, now this volume 2, Y1, Y2. Okay, now to find the difference in volume. Y2 will obviously be greater. Okay, you'll get your you get your y. I'm just saying x and y because we don't know the numbers. Okay, thereafter you know the mass is x gram, your volume is, so after that I'll just put it here. Okay, mass is x grams, volume is y milliliter. So density, mass upon volume, mass is x grams, y milliliter, whatever. Okay, by knowing the values, by putting the numbers, you can just solve it. Okay, so so units is not given out here, but unit will obviously be gram per milliliter, okay, or kilogram per liter, depends upon CGS unit, SI unit, going up, going down. Okay, so basically the concept is, to find the density of something, you need to know the mass, you need to know the volume. If you know the mass, if you know the volume, you can directly calculate it and give it. But if you have a irregular solid, you can always use a measuring cylinder, and I showed you the method to do it. Okay, it's very easy. There is a can called a Eureka can. Okay, Eureka comes from the word by Archimedes, who was the person behind the concept of density, how density was discovered. He was the one who did it. So a Eureka can, if you have your textbooks with you, page number 17, there's a picture of it. Okay, it is a container with a spout portion below the top of the container. Okay, it is named so after the legend of Archimedes, when he apparently stepped into the public bath and realized that the volume of water that spilled over was equal to the volume of part of him that was in water. Okay, so this is what is also happening. See, so whenever we put the stone, this volume of water that is displaced is the volume that the stone is occupied out here. Okay, now he then jumped out and ran through the street shouting, "Eureka, Eureka," meaning I have found it. Eureka can is also called displacement vessel or an overflow jar. Basically, it is a structure like this. Okay, so from here the overflow water, whatever, will come up. So with the help of this also you can measure your volume. Okay, so there are few sums which we will be doing right now. We will be doing that later. So for now, so that should be more than enough. We're just starting it off because with the regular classes I could not continue. Okay, so we talked about density, we talked about the formula, we talked about mass, volume, and I told you the relationship. I talked about the measurement of density of irregular solids using measuring cylinder. Then we talked about the Eureka can. We'll just be doing that much. Thank you, children.